is represented as 0. Similarly for rest all the labels. So this is how one hot format encoding will work. So basically one hot encode function takes the input x, which is a list of labels. It's a kind of logical gate or ground truth. The total number of elements in the list is the total number of samples in a batch. This one hot encode function returns two-dimensional tensor where the number of rows is the size of the batch and the number of columns is the number of image classes, as explained and shown here in the diagram. So this diagram shows the pre-processing of given dataset. So it is clearly shown that we can see that these 10 percentage of data from different batches will be combined to form a validation test here. So, and the remaining 90% of data will be used for training. This 90% and this 90% and so on with all batches of 90% of data is used for training. Finally, there is a testing dataset that is already provided. Here comes the code in which it is image data. We need to make it ready to fed into first convolutional layer. So here we are setting up images for training and for testing as well. So the next part here, after finishing of setting up the images for training and testing process, here is the major part where for building model process. The three major steps for building a convolutional model is filtering, strides, and padding. So what is filtering? In the context of convolutional neural network, a filter is a set of learnable weights which are learned using the back propagation algorithm. So we can think of each filter as storing a single pattern or a template. So what are strides? Strides are useful to determine how much window of filter should be moved for each evolving step. It is a parameter of neural network filter that modifies the amount of movement over the image or video. So for example, in our project, if the neural network stride is set to 1, the filter will move 1 pixel or 1 unit at a time. And once the whole process of convolution is done, the output size of the image gets smaller than the input. So here we use padding equals to same. So this statement is really helpful to keep the output size of the image to remain same as the size of the input image. On the other hand, it will be smaller when the padding is set as valid. Here we are using padding equals to same to make it easier to manage the sizes of image in every convolutional layer. So the next step here is in building convolutional neural network is to use the ReLU activation function. Basically, this activation function takes an input value and outputs a new value ranging from 0 to infinity. When the input value is somewhat large, the output value increases linearly. However, when the input value is somewhat small, output value reaches maximum value of 0. So when considering with the image dataset, all the values are originally ranged from 0 to 255. This sounds like which it is passed to a sigmoid function. So here we are using the ReLU function and max pooling function in this code. So the max pooling function helps to downscales the image with proper size. A pooling layer is another building block of CNN. Its function is to progressively reduce the spatial size of representation to reduce the amount of parameters. So the most common approach used in pooling is max pooling. We can also use dropout to prevent the overfitting sized images in order to keep the output appropriate and accurate. The next step here is to create second convolutional layer. As we all know the working of CNN model, the outputs of the first convolutional layer is taken as input to the second convolutional layer in this step. Here we are also creating second max pooling layer to reduce the spatial size. So here this is the code for max pooling layer as well as the convolutional layer. So after building the second convolutional layer and second pooling layer, we use some dropout command to remove the overly fitted images. And we also use here softmax in order to defining the loss function, and because we need to minimize the cost optimization function here. So the next step here is using Adam optimizer function, in which it is used to minimize the cost by applying specific algorithm. There are different algorithms like AdaGrade, Adam optimizer. In our project we are using Adam optimizer. In phase 2, the step is to train and test the CNN model. So this function runs on optimization task on the given batch of data. It will be used to inside the loop over a number of epochs and batches. Session run takes, so this is the command which is used that take care of the job. It takes the first argument as what to run and the second argument as a list of data to feed the network for retrieving results from first argument. As mentioned and explained in the previous slide, we want to minimize the cost by running optimizer, so that has to be the first argument. So here comes the final step of testing accuracy of our CNN model. The accuracy percentage here is displayed with batches. We have taken here steps of 5000 with 100 batches. So the final accuracy percentage here is 65.61 for the step 5000 with 100 batches. So we can say that there is 65% accuracy of classifying the images with CIFAR 10 dataset using and building CNN model. So that's all for this video, and we will discuss the rest of the parts in next video.